Hey guys, welcome back to CBSE Elites. Today we'll be starting with Surface Chemistry Part 2 Adsorption Isotherms. So, what are adsorption isotherms? It is the variation in the amount of gas that is adsorbed by the adsorbent with some pressure at some constant temperature. Okay, so it is the variation of amount of gas with but what are the conditions? The pressure, there is some pressure and there is some constant temperature. Okay, and how is it expressed? By means of a curve. So when it is expressed by means of a curve, then it is known as adsorption isotherm. Okay, so now we go move on to Freundlich adsorption isotherm or Freundlich isotherm. So this guy, Freundlich, in 1909 gave an empirical relationship, gave a relationship between the quantity of gas that is adsorbed by unit mass of the solid adsorbent and pressure at a particular temperature. So what is he saying there? It is a relationship between the quantity of gas. Here also we discuss the amount of gas. That is the same thing, quantity of gas. That is adsorbed by unit mass. Unit mass means 1 unit mass. 1 unit mass of solid adsorbent. Solid adsorbent and pressure at a particular temperature. Okay. Now, how can this relationship be expressed? It can be expressed with this equation. This is an equation which you need to keep in mind. That is x by m. X by m equals to k, which is constant, p, which is pressure, 1 by n, where 1 by 2, where n is greater than 1. Okay, so let's continue. So x by m, mass pressure by mass, something like this. It is expressed on this side, y-axis. Okay, and pressure is expressed at x-axis. So this is something which we get as a graph of adsorption isotherm. Now what is x here? In the equation we just studied, what is x? What is this x for? Okay, so let's see. X is the mass of gas adsorbed on the mass of adsorbent at pressure T. Okay, and K are the constant which N and K are the constant which depend on the nature of adsorbent and the gas at particular temperature. So X is the mass of the gas. Now the relationship is generally represented in the form of a curve which we studied just earlier, where mass of the gas adsorbed per gram adsorbent is plotted against the temperature. Here comes the mass of the gas adsorbed. Here comes the adsorbent mass by temperature. This is the x-axis, this is the y-axis if I have to remind you. Now, at this particular temperature, the variation graph comes like this. Okay. And at this temperature, it just goes a little up, and after this temperature, it goes more up. So what can you conclude with this? As the temperature decreases, the graph's curve increases. These curves are indicating a fixed pressure and there is a decrease in physical absorption with increase in temperature. As physical absorption decreases with increase in temperature, that is why the curve gets shorter. See, this is the difference. If you want to see, so curve gets shorter, or there is a decrease in the curve, you can say. These curves are always seeming to approach saturation at a high pressure, just as this. Okay, now let's move on. Taking log on both sides of the equation. Now what did we do? What was your original equation? X by m equals to k dot p 1 by 2, where n is greater than 1. So when I took the log on both the sides, I got log x by m equals to log k plus 1 by n log p. If you have studied the log, you will understand this. Basically, the power came here in the multiplication, and the multiplication just went to addition. So this is something we get where this is the validity of Freundlich isotherm. Now, if you plot a graph between log x by m and log p, something like just like we take log on these both sides. Okay, then where log k is the intercept and slope is 1 by n. So this 1 by n gives me the slope of this graph. Okay, so now the validity of Freundlich isotherm can be verified by plotting the x by m and log p graph, ordinate and at ordinate and abscissa respectively. So this graph is plot just to check the validity of the Freundlich isotherm. If it comes to be a straight line, the Freundlich isotherm is valid, otherwise it's not. So when you take out the Freundlich isotherm for some particular thing with this formula and you need to verify that it is correct, what do? You take the log on both sides and plot a graph the slope of which should come a straight line, and if it does, then it is correct. Okay, now here the slope of the straight line gives you the value of 1 by n. When you take out the slope, you get the value of 1 by n, or you can say that 1 by n here is the slope. The intercept on x-axis give you the value of log k. Okay, now how can we take out this part and then take the antilog and find x by m if we want to? If you have got the graph, okay, now the intercept here suppose is 1, for example. So log k, what will be log k equal to? It will be equal to 1. Okay, and 1 by n suppose equals to 1 by 2. Then this 1 by n will be equal to 1 by 2, and the pressure log p will be given to you. So this makes you find out what is log n. You can take anti-log of it and find out the value. a constant, so x is directly proportional to P, and P is inversely proportional to M. Okay, the adsorption varies directly with pressure. So when it is independent of pressure, when it is zero, and it varies directly with pressure when it is 1. Okay, both the conditions are supported by experimental results. The experimental result isotherms always seem to approach saturation at higher pressure. This cannot be explained by Friendlich isotherm, thus it fails higher pressure. So it the experimental isotherm always approaches to saturation at higher pressure, and it cannot be explained by isotherm. So it does not hold true at high pressure. Now, adsorption from solution phase. Solids can adsorb solutes from solutions also. When a solution of a as in acid in acetic acid is shaken with charcoal, a part of it is adsorbed by charcoal and then concentration of acid decreases in the solution. The following observations can be made. Now these observations are something which are important. What are those? The extent of adsorption decreases with increase in temperature. So it decreases as the temperature increases. As and when the adsorption extent is decreasing, the temperature there is increasing. The extent of adsorption, now here the extent of adsorption increases with increase in surface area. So what can you say here? Adsorption is inversely proportional to temperature, and adsorption is directly proportional to surface area. The extent of adsorption depends on concentration of solute in the solution. Whose concentration? Solute's concentration. The extent of adsorption depends on nature of adsorbent and the adsorbate. So what are the things we need to keep in mind? It In the solution phase, adsorption decreases with increase in pressure. That means adsorption is inversely proportional to temperature, and adsorption increases with increase in surface area. That means adsorption is directly proportional to surface area, and the extent of adsorption depends on the concentration of solute in the solution, and the extent of adsorption depends on the nature of adsorbent and the adsorbate. These 4 points are very necessary to remember, and this representation also. This is something which can have a direct question in your paper. Next, move on. Friendlich equation approximately describes the behavior of adsorption from solution with a difference in that instead of pressure, concentration of the solution is taken into account. So now what we do? Instead of pressure, we are taking the concentration of the solution. So what did we do? We just changed this. The concentration I have changed with the pressure. There was pressure, and then I have changed it with concentration. So the equation which was x by m equals to k p 1 by n now becomes x by m k c 1 by n. Now where c is the equilibrium concentration, that is, what is equilibrium concentration now? When adsorption is complete. Now whenever the adsorption is complete, at that point of time, whatever the concentration of the solution is, that is denoted by c. On taking the logarithm, this is what we get. just in place of log C, we get log P, we get log C. Plotting log x by m against log C, a straight line is obtained, which shows the validity of Freundlich's isotherm. This can be tested experimentally by taking solutions of different concentrations of acetic acid. Equal volumes of solution are added to equal amounts of charcoal in different flasks. So this is something which we can experimentally test. If you want to test, or sometimes it is this practical is done in schools. So you take different solutions. Absorb the poisonous gases from getting inside your mouth, or getting it inside before you inhale that. So these are some things which are used in coal mines because there are very poisonous and toxic gases over there. This point is something which can be asked in the exam. Now next is control of humidity. Now, silica and aluminum gels are mostly used as adsorbents for removing moisture and controlling the humidity. So, wherever there is a huge amount of humidity, or there's a lot of humidity, there we use silica and aluminum gels, and they help in removing the moisture. They adsorb the water and the moisture, and they control the humidity. Next comes removal of coloring matter from solutions. So here animal charcoal removes the colors in solution by adsorbing the color impurities. So as the color impurities are adsorbed, the original color is obtained. Now heterogeneous catalysis. Adsorption of reactants on solid catalyst increases the rate of reaction. Okay, there are many gas reaction of industrial importance involving the solid catalysts. Then comes the separation of inert gases. Due to the difference in degree of adsorption of gases by charcoal, a mixture of noble gases can be separated on coconut charcoal at different temperatures. So where there is a mixture of inert gases, noble gases can be separated because difference in degree of adsorption of gases, there is a different degrees with on which every the particular gas gets adsorbed on charcoal. So because of that we can separate the gases. Now next is curing diseases. A numerous drugs are used to kill germs by getting adsorbed on them. So this is something which is uh, something technical. What they do, they the drugs that we take when which are said to kill the germs, they what actually do, they adsorb them on their surface. Next comes the flotation process. A low grade sulfide ore is concentrated by separating it from silica and earthly matter. By this method, using a pine oil and frothing agent. So what are you doing? A low grade sulfide ore. Sulfide ore, when we want to separate the sulfide ore from silica and other earthly matters, then so they at different stages they get adsorbed. Particular things get adsorbed. Next is adsorption indicators. Surfaces of certain precipitates such as silver have property of adsorbing some dyes like eosin, fluorescein, etc., and thereby producing a characteristic color at end point. Now last comes the chromatographic analysis. What is this? This is something which you do in lab, and this comes in a practical exam as a practical. So chromatographic analysis is based on the phenomenon of adsorption, finds a number of applications in analytical and industrial fields. So the color, the adsorption of different colors of particular ink takes place at different steps, and this based on this phenomena of adsorption, there is an analytical and industrial fields test. So this is it for today's class. Now in next class we'll be starting with catalysis. Until then, thank you for watching. Do subscribe. Thank you.